We are on day 6 of quarantine, AMI day 7. I don't know how many times I've said it in these last 2 weeks, but it's crazy that I'm having to talk to you over a computer instead of seeing your faces every day and hearing your griping and complaining and your joyous laughters and your just excitement to see everybody. It's really eerie and daunting in the hallways to walk in and not hear a single child speak. So you are missed, you are loved, but you do have work to do. So don't think that you don't have any work that you've got to complete. You need to get to work. And today, like I said, it is quarantine day 6. I know it feels like we should be further along on AMI days just because we had a whole week of spring break. Some of y'all really didn't take much of a spring break because you were doing your chronication, which means you were staying home. And some of you even pulled out your days 7 through 10 and started working on those just because you were so bored and wanted something to do. If you did not work on day 7 through 10, or if you are still working on days 2 through 6, go back through my YouTube channel and watch those videos. Make sure you watch those before you call me, before you reach out to me, because I explain a whole lot of things that you need to know on those. So today we are looking at vectors on a map. So vectors on a map. Oh, and I should not have done that. My bad. So you're going to need, of course, a writing utensil, a piece of paper, or the bottom of the page provided. So if you went ahead and you printed off today's work, it should look, this is the second page, and this is your first page. On the first page, it gives you a little reminder of vectors on a map. We did this stuff back in September, and then a quick little example of how to find vectors on a map. And then on the second page are the 4 questions. The 5th one is just a bonus if you want to do it. So I'm going to do 4 of these. And then, excuse me, Mr. Little is calling. I just have to wait for a minute. And then on the 5th one is just bonus. So on this, you can even see I've got my grids all set up down there. I'll pull this up and make it bigger in just a minute. Let's see if maybe I can see it better here. Yeah, I can. I got my grid set up. I've got my 1, 2, and then 3 and 4 set up. So you will need some grids. You will have to have some little room for some math. Yes, I know you all love math so much, but remember, science and math go hand in hand. Without math, we don't have anything that can support our findings. So we have to know a little bit about math. And then your AMI Day 7 4.1 vectors on a map. You might even need a calculator. If you cannot do some of this stuff in your head, which we will do some conversions. I know you love it. So you might even need a calculator, and I forgot to put that up here when I was making this slide. Your assignment today is to first read the review lesson over vectors on a map and then do the one example. So that first page that I gave you, or that first page that you have, this is just a review. This is for you to go back through and remind yourself about vectors and what vectors are. And then if you need extra help, I've even put on the front page. If you look at this front page, I even put on here where you can go online to find the online ebook for physical science. Let's go ahead and let's go to that real quick online, just so you can see where it is. I'm going to click on it, and if my computer, it is so slow and taking its sweet little time, it's going to pop up the ebook for you. This is phone compatible, that's the word, compatible. And so it's nothing that is too hard to look up. You can just turn your phone to the side and you'll be able to see it better. You're going to click on Unit 2, Motion and Forces. From there, you're going to click on Motion, and it's going to take you exactly to where we need to go. It says you need to look at pages 81 through 85. So I'm going to go ahead and flip over to 81. Oh, there it is. Click off of this real fast. And it gives you vectors and velocity. So if still, even after reading the review or looking through the example, you still cannot remember what to do, read through these pages in your e-notebook. Look through them. Remember, it's all about position, and vectors just has to deal with the velocity to speed, and that someone was moving over amount of time times the distance that they covered. And so this even gives you a little bit more help when it comes to maps and vectors. Remember, we looked at this when we talked about Sojourner and when we discussed the way that Roombas work in a room and how they work off of a grid. All right. So if the link does not work for you, you can just type in, and I'm not a big fan of Internet Explorer. Let me get rid of that real quick. And let's go to the school website. From the school website, you can go to directory, and this is looking for the book online. So I give you the link. If the link's not working for you, if you just cannot figure out how to type it in, go to Lamar Warriors, click on directory. From directory, it's going to pop up all the teachers' names. I'm going to type in my name, Judith Little. I'm going to go to search. Then below, you're going to see my face where it says view website. Click on view website. And there, I'm going to scroll down to where it says Foundations of Physical Science book. It even says click on link. You must click on the link to get to it. And there it is. Click it. Click the bottom. Unit 1 is what they're, no, sorry, it's Unit 2, Motions and Forces. Click out of that. Go to Motion. That's page 77. I can even type in page 81. Whew, there it is. Read through it. You're not helping yourself if you just guess on this work. These are things that you do need to know for next year when you go to biology. Okay, so that is where the book is. So now let's do some examples real fast. So that's everything we need. Here is our first example. It says, and even if you want to read along with me on your paper that I gave you, the question, your home is at the origin. From there, you ride your bicycle to the movie theater. You ride 30 kilometers per hour north for 0.50 hours. And then 20 kilometers per hour east for 0.25 hours. The first question I'm going to ask myself, and I'm going to go to the board for this one to help y'all out. Okay, first question I always ask is, what am I looking for? And I know on here it already gave you a grid to work off of, and it told you where your home was at a 0, 0, and it went on ahead and found your movie theater having having a vector of plus 5 kilometers and plus 15 kilometers. But I want the math. I want to see exactly how they did that. So the first thing they asked themselves is which direction, or let's go back to what question am I looking for? My question was, I want to know, going from home, which is my origin, where did I go vector-wise on a grid? So I'm going to say, my first thing that, what do I know? It says, from there you ride from my home, which is my origin. I'm going to ride on my bicycle to the movie theater. You ride 30 kilometers per hour north for 0.50 hours. That is my first thing to look at. It gave me my direction as north. So I'm going to write on my piece of paper in, because I know that I'm heading in a northern direction. Then it says that I'm going 30 kilometers per hour at 0.50 hours, or 30 minutes is what we know in our head. And I can use the formula, the change in position formula, that says my position equals my velocity times my time. Or if we want to think about it when it comes to units, remember, velocity is our distance over time times time. And when we have a variable on its own, we automatically know there's a 1 underneath it. So when I multiply these together, our times are going to cross out, and it's just going to leave me with the distance. And that's all I want to know is the position, the distance that I traveled, or the position at which I'm going to stop from my origin. So I'm going to set this up the same way that I set up my position. So it says I'm heading north at a velocity. So this is my velocity. This is my time. I'll multiply my 30 kilometers per hour times my 0.50 hours. My hour is going to cross out because this is in the numerator. My hour's over here in the denominator, so those two cross out. And then 30 times 0.50 is just 15 kilometers. Okay, so that's one direction I've headed. So now I know I've gone from home and I have traveled up 15 kilometers. But that's just my y. I need to know what is my x. So then my x, it says, and then travel 20 kilometers per hour east for 0.25 hours. So now I'm going to look at my eastern direction. So this we said is our y, and this is our x. And it even shows us up here, our x is on our independent, our y is on our dependent. And so east is heading, it says that we're going to head 20 kilometers per hour. We're going to use this same equation up here, this exact same equation, and we're having a time of 0.25 hours. So I know I can go ahead and cancel out my hours. This one's in my numerator, this one's in my denominator, and then just carry out the mathematical multiplication of 20 times 0.25, and that is 5 kilometers. So it said that we had an x over x. So I shouldn't have done that. I apologize. And I had it over x. You should always look at your x and then your y. So you're saying that you're traveling on an x 5 kilometers and then up 15. Does everybody see that? Because the way that we would write this vector, we would say our x goes first, because we always put it in our vector format. So x is our 5 kilometers by our 15 kilometers. So you actually headed over 5 kilometers and up 15, and that's how you would draw it on a map. I know it says they first went 15, and yes, they did, and then over 5. But we would write it in an XY situation. All right, so let's do number 1 together, because I'm probably more than likely that's what Miss Little does is confuses you. So let's do number 1 together. Number 1 says Augustine and Edson. So we have 2 friends, Augustine and Edson, are going to a baseball game. To get to the stadium, they travel east on the highway at 120 kilometers per hour for 30 minutes. Then they turn onto the stadium parkway and travel south at 60 kilometers per hour for 20 minutes. Assume their starting point is at the origin. What is the position of the stadium? Always ask yourself in anything scientific, what is my question? What am I looking to answer? So if you reread back through that practice question, it has an actual sentence that has a question mark. What is the position of the stadium? So we're wanting to know if we started out at our origin, which our origin is our starting point, going to be our 0, 0. So we know that our origin is going to be 0, 0 on a grid. We want to know, where did we go from 0, 0 to the stadium? So then we ask ourselves, the second question is, what do we know? What is the given? What are they telling us about traveling? So they first said they traveled east on the highway 120 kilometers per hour for 30 minutes. What does east tell us? It tells us our x or our y. So let's remember, on a grid, we have just the same way that you would use a compass. We've got north, south, east, and west. Our north and south, our north and south is our y, our east and west is our x. So we know that east, this is going to be our x. On the highway, 120 kilometers per hour. If we're looking at distance divided by time, that is telling us our velocity. And then we went at 120 kilometers per hour. They went at 120 kilometers per hour for 30 minutes. And so that is our time. And then they turned into the stadium parkway and traveled south at 60 kilometers per hour for 60 minutes. So south, we know, is on our y-axis. So this is our y. At 60 kilometers per hour, this is our distance over our time. So that's our velocity for 10 minutes. So this is our time. And we're going to assume their starting point, of course, that we said. And it even says that assume their starting point is at 0, 0. So now what we've got to do is find their positions. So we're going to look for where Augustine and Edson traveled. And we're going to use the equation that change in position equals velocity. Remember, velocity is distance over time times the change in time. Ooh, that one did not change for me. So first we're going to solve. They travel east on the highway at 120 kilometers per hour for 30 minutes. So this is our x, this is our velocity, and this is our time. But we need to look, do the units match? Always double check that your units match. You cannot automatically say that I'm going to multiply 120 times 30 when your minutes are not the same as hour. You have to convert that. So in order to convert from minutes to hours, remember, we start out 30 minutes on the top, set up our conversion chart. We want to get rid of minutes, so it goes in our denominator, and we want to find out what it is in hours, so hours go in our numerator. So then I'm going to ask myself, how many minutes are there in 1 hour? You said 60, you're correct. There are 60 minutes in 1 hour. So then this is where you might need to get out your calculator if you cannot just do this in your head. So I'm going to divide, because minutes cancel out. I'm going to divide 30 divided by 60 times 1, and I get 0.5, and that's an hour. So now I've converted, so it's no longer 30 minutes. It's now 0.5 hours. Okay, so now we want to find the position traveling east. So our position traveling east, whoops, let's get rid of that. Position traveling east, we're just going to log in our position equals our velocity times our time. So we're going to say that it is 120 kilometers per hour times the 0.5 hours. Hours cross out. So then we're just going to multiply. So what is 120 times 0.5? We've gotten 60 kilometers. Remember, this one is heading east. We're heading east 60 kilometers. All right, so now we have found our traveling east. Now we're going to look and it says, then they turn onto the Stadium Parkway and travel south at 60 kilometers per hour for 120 minutes. So south is our direction, so we know this is our y. 60 kilometers per hour, this is our velocity. 10 minutes, this is our time. But then we've got to look, do the units match? They don't. We've got 10 minutes to an hour. So we need to convert our 10 minutes the same way that we converted up here over 60 minutes, because there's 60 minutes in 1 hour. And then we're just going to multiply. No, that's not right. We're going to divide 10 divided by 60. And it comes up to 0.1666667. This is where we look at sig figs. We look at sig figs. If you look back up where it says the 10 in the original, 10 points, that means that there are how many sig figs? Remember, that point is going to make that 2 sig figs. So I just need 2 sig figs. So I'm going to say 0.17. With that 6, we're going to make that go up to 7. All right. So now find the position traveling south. So I'm going to find my position. I'm going to say I've got my 60 kilometers per hour. Multiply that by 0.17 hours, because we have converted those. So 60 times 0.17. We got it at 10.2 kilometers. We're just going to round that up to, or round that down to 10. Okay, so now that is your south, not north, south equals 10 kilometers. So we said our east was 60 kilometers, our south was 10 kilometers. So we'll put that into an x, y. So it says our starting is at 0, 0. We said our east was at 60. East is x. And we said our south was at 10. And south is y. This is set up in what is called the x, y. Now we're going to draw that using a grid. So we said we started at 0. 0, 0 is our starting point. I'm going to write that. Do this in a different color. Yeah, it looks better. Huge props. Let's just get rid of that whole thing. Okay. Yes, okay. And then I'm going to put my origin starts at 0, 0. Now I need to find, using my coordinates over here, it says that my x is at 60 kilometers, so if it's at a plus 60, that means I'm heading to the right. And if I'm going by, let's go into 60, I am probably going to do my increments by 20. To get these good and spaced out, you should be using a ruler, but for time's sake, I'm not going to. And so then it says my y, I go south. So if I'm going south, that should be a negative, correct? Maybe one of you caught that before I caught it. So it's negative 10 kilometers. So because I'm going negative 10, I'm going to go by 2, 4, 6, 8, 10. And now I'm just going to plot my point. So it says that they went over to 60 kilometers east, and then they headed south 10 kilometers. So this is 60 kilometers, 10 kilometers, and this is the stadium. I know that looked like a whole lot of work. But the only reason it looked like so much is because I wanted to work it with you. I wanted to go with it step by step with you to where you would not be completely and totally confused. So that's it. That's all I'm asking of you to do for today. And I've already done number 1 with you. So if I've already done number 1, let me get myself situated. I felt really short. Since I've already done number 1 with you, all you got to do is 2, 3, and 4 on your own, and the 5th one for bonus. I don't think that's too much. If you need me, call me. You've got my number. If you still have questions, email me at judith.little@lamarwarriors.org. I will be posting more videos for the rest of the week because a lot of it does have to do with vectors and map and graphing and finding slope. Very important information that you will need to know for the rest of your life. If you want to read a map correctly, you need to know how to find vectors. If you want to figure out how quick you can get from point A to point B, you need to understand vectors. So, all right, love you lots. Holler at me if you need me. Check your email. I did send some messages out to some of y'all, actually to all of y'all. Email me back if you want to. Let me know if anything's going on and you need help. All right, bye guys.